diagrams showing some types of functions. You have to tell me the differences in this. Okay. I'll try to draw 4 types of functions. All of them are functions, but you have to tell me the differences. Just by mapping, I'm showing this. And this is a very effective way to understand the differences. Okay. I'll also number them so that you can recognize which one I'm talking about. So 4 functions, quickly I'm going to write this so you don't have to worry. Try to observe the way I'm writing. So why am I writing in front of you without writing it in the beginning? I mean, keeping it as a ready figure is, I want you to observe the way I'm writing it so that you can observe the differences. Okay. So now look at this. Is it a function? Any doubt in this? Yes. First one is a function. All of them are function. Okay. If you can see there's any, I mean, if there's not a function, you can let me know. Is this a function? Yes. Every element in A has one image in the B. Okay. Is this a function? Yes. Is this a function? Yes. But what is the major difference between these 4 types of functions here is each of them are unique in their own way. What is it? It all depends upon how many elements are related in the second set. Here, what is the domain? What is the domain of this function? All the elements must be, see, remember domain is nothing but all the elements, because every element should have an image. So every element is being used. But here, every element is not being used. One is not being used. That is one significant thing to note. The second thing is A has 2 pre-image. Okay. Here, 2 has 2 pre-image. Okay. So this, if this is not happening, whereas here 1, 2, 3, each of them are only one image, and here each of them are only one image, right? So such a function is called 1-to-1. Remember, 1-to-1 functions. Okay. So which are 1-to-1 now? So I can see clearly in this example, second mapping, that is second function and third function are 1-to-1. Okay. Then what are these? 1 and 4. 1 and 4, actually we have a name for them, many to one, because more than one element is connected to that. Okay, so many to one, we don't use it much. But just remember, it is not 1-to-1. Now coming to the second type I wanted to observe is the in this case A has 2 pre-images and 2 has 2 pre-images, whereas these 2 functions, they have only one image. That's why they're called 1-to-1. Another important observation is in this particular function, D is not being used. That means codomain is different from range. Range is just a proper subset of codomain. That is, one element in the codomain is not being used, right? Same thing is happening here. But observe these two. In these two, all the elements are being used. So they are called onto. So what is the observation? If every element in the second set is being used, that is called onto function. Okay. If every element in the first set has exactly one image, it is called 1-to. Okay. So there are other names for this. Onto means surjective, and 1-to-1 means injective. Just remember these names as well. Okay. Suppose if there is a function which is both 1 to 1 and on to, there is a special name for that. That is very important for us for the next part. They are called bijective. Now, can you tell me in these four examples, which is both 1 to 1 and on to? That is function 3. So function 3 is definitely, what is it? Bijective in nature. So function 3 is definitely bijective in nature. So let us see what are the mathematical terms used to represent this and how are we defining this quickly. Okay. Hope this is clear. Please take a screenshot of it. If that is not clear, you can just go through that again. Okay. So I might have to go to the next set quickly. Right? Yes. Yes, all this is being discussed. Okay, so there's a definition. We can see how to define one-to-one function, right? So for every x1 in a function, f of x to y is defined as 1 to 1. Suppose if f of x1 is equal to f of x2, that must necessarily mean that x1 must be equal to x2. That is, if f of x1 is equal to f of x2, then x1 must be nothing but x2. That means x1 if not equal to x2, then what will happen? Both x1 and x2 will have how many images? Will have more than one image, right? That is not happening. That must not happen. So whenever two different elements have the same image, those elements should not be different. That's the meaning indirectly. Okay. So that's how we are defining one-to-one function. Yes. So every element of y is said to be image of some element of x under the function such that f of x is equal to y for every y. What do you mean by that? Every element of set y. That means we have to use, as I told you, every element in the second set must be used or must be image of at least some of them in the first one. That means every element has to be used here. That is our way to say what is onto function. Okay. So anyway, we have discussed all this. One important thing to remember is in case of onto, codomain and range, both are going to be one and the same. Okay. Now quickly coming to the significance of the functions which are both one-to-one as well as on-to, that is bijective functions. Why we need to know why we need to understand bijective function is, for example, if a function is bijective, let me take an example. What is bijective? We discussed already. It has to be both one-to-one as well as what? It has to be both one-to-one as well as on-to. If a function is bijective, if I reverse the direction, that means the relation from a to b is bijective function. Okay. Now if I do the same thing, see here a, b, c, d, and same 1, 2, 3, 4. I will change the direction, but the relation remains same. A is connected to here. The function is 1, comma a, and 2, comma d. Here 3, comma b, and 4, comma c. This is the function, right? Now here, same thing. I need to write in the reverse direction. That is a, comma 1, b, comma 2, b, comma 3, and then 4, comma c, comma 4. Right? So you can see that. So I have to relate in such a way that c is related to 4 and b is related to 3 and then d is related to 2. So isn't it reverse of this function? Yes. And this is also a function? Yes. So whenever you come across a bijective function, when you change the direction, that remains still a function. Remember, that is possible only for bijective function, and this is nothing but inverse of this function. So I can say a function can be inverted or inverse of a function exists only if it is bijective. And what is bijective? A bijective is nothing but what? A function which is both onto and one-to-one. If it is not one-to-one, when you reverse, it will not become a function. The fundamental definition of function won't be applicable when you reverse the direction. That is why one-to-one is compulsory. On-to means when you reverse it, some of the element may not have an image in the reverse direction. That is why if it is not onto also, you won't be getting a function. That is why if a function is both onto as well as one-to-one, when you invert it, it remains still a function. That's why we say inverse of a function exists only for a bijective functions.